Progress in Optical Access Standards. Joint E2/IEEE Workshop on Ethernet, Emerging Applications and Technologies, Geneva, Switzerland, 22 September 2012. Progress in Optical Access Standards. Frank Effenberger, Rapporteur Q2/15. VP Access R&D, Futurvi, Agenda, PON Evolution. GPON. NGPON1 equals XGPON. NGPON2 equals TWDM-PON. Other topics. Capacity trend for PON 250G bandwidth 250G 100G 100G 40G 40G 40G. Downstream. Upstream. 10G. 10G. 2.5G. 0.6G. 0.15G. 0.05G. Generation. 1994. PON. 1999. APON. BPON. 2004. GPON. JPON. 2009. NGPON1. XGPON. 10GPON. 2014. NGPON2. TWDM-PON. 2020 plus. NGPON3. GPON, widely deployed. System defined in the G.984 series. G.984.1, System Requirements. G.984.2, PMD Specifications. G.984.3, TC Specifications. G.984.4, OMSI, subsumed by G.988. Now used for all E2PONs and peer-to-peer systems. G.984.5, WDM matters for the future. G.984.6, Reach Extension. G.984.7, Long Reach. Plus supplements. Standards considered stable and mature. Minor optional enhancements continue even now. XGPON1 system, G.987 series, coexisting with GPON. GPON OLT. GPON ONU. GPON. OLT. MAC. Logic. OLT Texas. 1490 nanometers. ONU RX. 1490 nanometers. GPON. ONU. MAC. Logic. NNI. Data. I/O. UNI. Data. I/O. WDM. 1490 nanometers. WDM. OLT RX. 1310 nanometers. ONU Texas. 1310 nanometers. 1577 nanometers. WDM1. XGPON OLT. XGPON ONU. 1310 nanometers. XGPON. OLT. MAC. Logic. OLT Texas. 1577 nanometers. ONU RX. 1577 nanometers. XGPON. ONU. MAC. Logic. NNI. Data. I/O. UNI. Data. I/O. 1270 nanometers. WDM. WDM. OLT RX. 1270 nanometers. ONU Texas. 1270 nanometers. XGPON1 PMD specifications, G.987.2. 6 OLT types and 2 ONU types. 4 loss budgets in all. N10LT. Texas, +2 +6. RX, -7 -27.5. N2AOLT. Texas, +4 +8. RX, -9 -29.5. E10LT. Texas, +6 +10. RX, -11 -31.5. E2AOLT. Texas, +8 +12. RX, -11 -31.5. N2BOLT. Texas, +10.5 +12.5. RX, -9 -29.5. E2BOLT. Texas, +14.5 +16.5. RX, -13 -33.5. 29 decibels. 31 decibels. 33 decibels. 35 decibels. 31 decibels. 35 decibels. APDONU. Texas, +2 +7. RX, -8 -28. PINONU. Texas, +2 +7. RX, -3.5 -22.5. XG-PON TC layer structure, G.987.3. The XG-PON TC layer is broken into 3 layers. Simplified implementation. Improved extensibility. Service adaptation sublayer. Encapsulated users' data. Interfaces with framing layer. Framing sublayer. Implements essential TDMA. Control and signaling. PHY adaptation sublayer. Encapsulates frame and interfaces with PHY layer. First XG-PON trial in the world. March 2010, NG-PON 2, Technology Map. PON 64. DWDM. PON. OFDM. PON 16. 2. 3. TWDM. PON. Number of wavelengths. 4. 4. 1. A. PON. B. PON. G. PON. XG. PON. XLG. PON. 1. 155M. 622M. 2.5G. 10G. 40G. Bitrate. 1. XLG PON 40G/10G TDM PON 10G APDBMR reused NG PON PR30. Add BM-EDC to gain 2 decibels. BM-DML. 10G DML Texas. Reuse 10G upon PR30. 40 km reach. 40 km distance. 31 decibels loss budget. ONU. OLT. 1:N. 10G US. EDC. BM-APDRX. Logic. Logic. APDRX. Bit interleaving protocol. Dynamic bandwidth. User rate ONU electronics. 20 GHz APDRX. Duobinary demodulation, electrical. Efficient FEC, for example LDPC. -22 dBm sensitivity. EML. SOA. 40G integrated EML plus SOA. Integration driven by XG-PON N2B. 40G duobinary modulation, electrical. Plus 10 dBm output. 40G DS. Duobinary modulation. Reduced BW allows use of 20 GHz APDs. Further mitigates CD by 3x. Downstream no band. Mitigates CD. Coexists with legacy, XGPON. 2. WDM mux-based WDM PONs, passive photonic loop. ONU 1. XCVR 1. ONU 2. XCVR 2. XCVR 3. WDM. MUX. WDM. MUX. ONU 3. Colorless ONU Type 1. ONU receives only one downstream wavelength. ONU must transmit on the correct upstream wavelength. 2AC. Wavelength injection types. 2A. External injection. 2B. Wavelength reuse. ONU. ELFP. RX. Logic. OLT. DFB Texas. ACE. Seed. Texas/RX. AWG. RSOA. 1535. 1560. ACE Light. ACE Slice. After locking. Before locking. Reflective. Zone. Gain. ACE Slice in. Amplified light out. ONU. RSOA. RX. Logic. OLT. DFB Texas. Texas/RX. AWG. Power. Splitter. Eye distortion. Reflective. Gain. Zone. 1535. 1560. RX lambda in. Amplified lambda out. 1. RX data modulation. 2C. Self-seated. ONU. ELFP. RX. Logic. OLT. RSOA. Texas/RX. AWG. 1535. 1560. After locking. Before locking. Reflective. Zone. Gain. ACE Slice in. Amplified light out. ACE Light. From. 2. Splitter-based WDM PONs, Lambda Net. ONU 1. Splitter. XCVR 1. ONU 2. XCVR 2. XCVR 3. WDM. MUX. ONU 3. Colorless ONU Type 2. ONU must tune to the correct downstream wavelength. ONU must transmit on the correct upstream wavelength. 2DE. Tunable ONUs 2D. Conventional tuned lasers and filters. OLT. RX. ONU. RX. Logic. Laser. Logic. DFB Texas. AWG. 1:N. Texas/RX. Texas/RX. 2E. Coherent receiver and modulator. OLT. Pol. Division. Coherent RX. Modulator. Texas. Texas/RX. AWG. Freak Gen. Logic. Lock OSC. ONU. Logic. Pol. Division. Coherent RX. Modulator. Texas. DSP. Control. Lock. OSC. 1:N. 3. OOFDM PON 3A. FDM PON 3C. OOFDM PON 3B. OFDM PON OLT Mod MAC. Lin. Texas. RX. OLT. 10G MAC. Lin. RX. Lynn, Texas. Medium BWO new. 40 GMAC. 2.5 GMAC. Modem. High BWO new. Low BWO new. RF frequency. Power. 3C. OOFDM PON. Low. Ball. RX. OLT. MAC. Plus. SERDS. ONU. IFFT. DAC. FFT. ADC. SERDS. MOD. POL. 3B. OFDM PON. Lynn. Texas. RX. OLT. Bitload. MAC. ONU. IFFT. DAC. Bit unload. FFT. ADC. RF frequency. Power. 4. TWDM PON, XG PON 2, key features, builds on XG PON 1. ZGPON 2 ONU 1.1. Logic. Laser. RX. XG PON 2 OLT. BMRX1. AWG. BMRX2. 1:N. BMRX8. ZGPON 2 ONU 2.1. Logic. Laser. RX. Logic. Texas Lambda 1. AWG. Texas Lambda 2. WDM1. ZGPON 2 ONU 8.1. Logic. Laser. RX. Texas Lambda 8. GPON OLT. Key features. Builds on XG PON 1. Uses splitter-based PON. GPON ONU. RF overlay. Advantages. Reasonable costs. Up to 80 gigabits per second. Coexists with deployed GPON. Challenges. Tunable receivers and transmitters at ONU. Spectrum allocation. NG-PON 2 architecture scorecard. OFDM PON. Fuji, ITRI, Hisense, NIOP, VEET, ZTE. TWDM. ALU, BL, CX, HW, MIT, OKI, PMC, ZTE. 40G serial. ALU. ELPON. LGE, ITRI. RUPON. ERIC. WDM, OFDM PON. NEC. SS PON. ALU, HW. TON PON. ADVA. OFDM PON. ALU. UDPON. NSN. Green equals selected. Yellow equals optional enhancement. Red means not this time. Approved TWDM system requirements. Base system, 40G downstream, 10G upstream. 4 channels in each direction. Compatible with GPON, XGPON, and RF video overlay. 20 km at 164 split ratio, fully passive plant capable. Optional extra capabilities. 8 channels in each direction. 10G upstream. DWDM overlay. Standardization is expected to complete July 2013. NG-PON 2 spectrum, rough consensus. 10 nanometers. XG-PON. Upstream. GPON. Upstream. 1260. 1270. 1280. 1290. 1300. 1310. 1320. 1330. 1340. 1350, 1360, NG2, 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 1530, 1531, 1532, 1533, 1534, 1535, 1536, 1600, 1601, 1602, 1603, 1604, 1605, 1606, GPON. Downstream, NG2, Video, XG, NG2, 1480, 1490, 1500, 1510, 1520, 1530, 1540, 1550, 1560, 1570, 1580, 1590, 1600, 1610. TWDM standards arrangement. G.PON 2.1 equals requirements. Consented at September 2012 meeting. G.PON 2.2 equals physical medium dependent layer. Draft in progress. G.PON 2.3 equals TC layer. NG-PON 2 specific TC features. G.987.3 equals transmission convergence layer. 10G upstream to be added to this base standard. G.multi equals wavelength control layer. Draft already started in Q2/15. G.988 equals ONU management and control interface. Standard in force, can be easily reused for TWDM. Other topics G.PON G.multi G.POC applies OMSI, G.988, to UPON. Relevant to P1904.1 Package B systems. G.multi describes generic multi-wavelength control in PON access systems. G.POC study of integrated PON G.fast systems. Objective of reducing DP complexity.